In the heart of the entertainment capital of Las Vegas, a massive unknown object suddenly appeared on the city's skyline, causing millions of eyes around the world to stop and stare. A glowing sphere like an artificial sun, covered with more than 1.2 million programmable LED nodes. People call it the Las Vegas sphere. With a total construction cost estimated at around $2.3 billion US, it is currently the most expensive entertainment venue in the city's history. But what makes the sphere truly remarkable is not only its glowing exterior shell, but the enormous immersive performance space inside, where the boundary between a theater, a stadium, and a cinema screen almost completely disappears. So how was such a gigantic steel sphere built in the middle of the Nevada desert? And is this a technological wonder of the 21st century? The city of Las Vegas has long been known for its distinctive and luxurious architectural style, home to some of the most iconic resort and casino complexes in the world. Therefore, in order to truly stand out, the Sphere had to deliver an experience unlike anything that had ever existed anywhere else. The idea for this project was proposed by James Dolan, chairman of Madison Square Garden Entertainment, with the goal of creating an entirely new generation of performance venues, where the building itself becomes a gigantic display screen. Construction of the project began in the year 2019, just behind the Venetian Resort Complex on Las Vegas Strip, with the ambition of building the largest spherical structure ever created, while integrating an LED display system covering the entire exterior surface of the building. After nearly 4 years of construction, the Sphere was officially completed in the year 2023, with a total cost of approximately $2.3 billion United States dollars, significantly higher than the construction cost of Burj Khalifa in Dubai, which was about $1.5 billion United States dollars. The structure quickly became a new entertainment landmark of Las Vegas and opened an entirely new direction for performance architecture in the 21st century. From the moment it appeared on the Las Vegas skyline, the Sphere was designed to become a structure that is impossible to ignore visually. With a height of 112 meters and a width of 157 meters, it is currently the largest spherical structure ever built in the world. Inside the structure is an auditorium with a capacity of more than 18,000 spectators, which can expand to nearly 20,000 people when hosting special events. The entire space is covered by a gigantic curved screen with an area of approximately 15,000 square meters and a resolution of up to 16K, creating a visual environment that surrounds nearly the entire field of view of the audience. Accompanying this is an advanced directional sound system consisting of more than 160,000 speakers. Instead of spreading sound throughout the space like traditional systems, the speaker arrays function like sound beams that are precisely directed to individual seating areas, creating an almost personalized listening experience inside an auditorium that accommodates tens of thousands of people, a technology that has almost never appeared before at theater scale. The experience inside the Sphere does not stop at visuals and sound. Motion-enabled seating, artificial wind effects, and synchronized scent systems are integrated to transform the entire performance into a complete journey for the senses. At the same time, all seating is arranged facing the center of the performance space, helping ensure unobstructed sightlines and maintaining a consistent immersive experience for every position inside the auditorium. From the outside, it is easy to see that the Sphere resembles nothing less than a gigantic visual stage in the middle of the desert. The entire exterior surface of the structure is covered with more than 1.2 million programmable LED nodes, turning the Sphere into the largest outdoor display ever implemented at architectural scale. This makes the building itself not only a performance venue, but also a media facade capable of transforming the appearance of the Las Vegas skyline in real time. To realize a spherical structure of unprecedented scale like the Sphere, the construction of the project effectively began with preparation work carried out deep below ground level, where the entire load-bearing foundation of the structure was established from the very beginning. The MSG Sphere officially broke ground in the year 2019, with a large-scale foundation construction phase that was almost invisible from the outside. Nearly 600 foundation piles were drilled deep into the ground, while approximately 84,000 cubic meters of material were excavated to create a basement system covering more than 5,000 square meters for backstage areas, technical rooms, and the entire operational infrastructure beneath the structure. From this foundation, 4 central concrete cores were erected and connected using more than 9,500 tons of steel, forming a ring beam system that supports the main dome, weighing up to 11,000 tons. To install these massive structural components at high elevation, one of the largest crawler cranes in the world was transported from Belgium to the construction site, and the assembly of this equipment alone required nearly 3 weeks to complete. After a temporary support tower approximately 86 meters tall was erected at the center of the structure, a compression ring weighing 154 tons was placed at the top and connected to 32 massive roof trusses. Once the temporary support system was removed, structural forces began to balance naturally within the frame, completing one of the largest column-free dome spaces ever constructed for a modern entertainment theater. One of the most technically complex stages of the project was the installation of the dome roof, using a double-ring rail system running along the perimeter of the structure. Large-capacity material lifting gantry systems move continuously along these rails, allowing precise positioning of heavy steel components during roof assembly and ensuring that construction progressed safely and efficiently. On this primary structural framework, the exterior spherical shell continued to take shape through a massive geodesic steel frame system. The load-bearing skeleton supporting more than 1.2 million programmable LED modules that create the sphere's distinctive appearance on the Las Vegas skyline. At the same time, inside the structure, engineers installed an interior steel support structure weighing approximately 730 tons to carry the curved LED display covering about 160,000 square feet, the centerpiece of the immersive visual experience inside the theater. An important milestone in the construction process was the official topping out ceremony, marking the completion of the main structural steel framework of the building. At a height of approximately 366 feet, the project entered its final finishing phase when construction crews raised a green pine tree together with the flag of the United States to the top of the structure according to a long-standing construction industry tradition, confirming that the final steel beam of the sphere had been installed. After the massive dome structure was fully enclosed and the exterior geodesic frame was completed, MSG Sphere was no longer simply a large-scale structural project, but began transforming into an entirely new form of media architecture in the middle of the Nevada desert, where the boundary between a construction structure and a performance infrastructure almost disappears. From this point onward, the sphere entered a phase in which every installed component no longer served only a load-bearing function, but also directly contributed to shaping the visual experience at an urban scale. With more than 1 million LED modules covering the entire spherical surface, the outer shell of the structure became an urban screen capable of changing continuously in real time, transforming the entire building into a living landmark on the Las Vegas skyline. At the same time, inside the structure, the giant curved display system, together with the column-free dome space, created an immersive performance environment that had never previously appeared in traditional theaters. It is precisely the combination of long-span spatial structure, high-density display technology, and industrial-scale content control systems that has made the sphere an important step forward in the way people design next-generation entertainment architecture, where architecture is no longer only a usable space, but also a platform for delivering experiences at the scale of an entire city. The success of the Sphere in Las Vegas quickly strengthened James Dolan's ambition to expand the Sphere model to London. According to the proposed plans, Sphere London will be a smaller sister version compared to the structure in Las Vegas, but it will still belong to the category of extremely large-scale entertainment megastructures. The project is expected to have a diameter of 120 meters, the same as the London Eye, and a height of 96 meters, equal to the height of Big Ben, With a capacity of 21,500 spectators and an estimated total investment of 975 million United States dollars, the project is expected to cost slightly less than the Sphere in Las Vegas while still maintaining a comparable experiential scale. If implemented, this will be the first Sphere structure to appear outside the United States, marking an important expansion of this immersive performance architecture model into major global urban centers. At the same time, the project also reflects the ambition to transform the Sphere not only into a single iconic structure, but into a next-generation entertainment infrastructure model capable of being replicated in multiple major cities around the world. And in vast desert landscapes like these, people are not only building iconic entertainment structures such as the Sphere, but are also laying the foundations for modern observatories designed to extend humanity's ability to observe far beyond the Earth itself. On the summit of Cerro Armazones in the desert region of Chile, the largest optical eye on the planet is gradually being completed. This is the most insane construction project in the history of astronomy. With a gigantic dome the size of the Roman Colosseum and a primary mirror nearly 40 meters wide, the extremely large telescope has the ability to collect light 100 million times greater than the human eye and deliver images 16 times sharper than the Hubble Space Telescope. When completed, it will allow humans to directly observe rocky planets outside the solar system and look deeper into the earliest period of the universe. So how can humanity build one of the most advanced cosmic observation machines in history under such harsh conditions? And how much further will this help expand our understanding of the universe? Over more than a century, each new generation of larger telescopes has opened a turning point in how humanity understands the universe. If the telescopes of the early 20th century helped us realize that the Milky Way is only one among countless galaxies, then the Hubble Space Telescope allowed humanity to look billions of light years deep into the past of the universe. But by the beginning of the 21st century, the observational limits of existing telescopes had begun to become a new barrier. For this reason, European Southern Observatory launched the Extremely Large Telescope project as a generational leap in space observation technology. The facility is being built at an altitude of more than 3,000 meters on the summit of Cerro Armazones in northern Chile, one of the regions with the best sky observation conditions on Earth. To reach this location, you must cross the Atacama Desert, one of the driest places on the Earth, situated between the Andes Mountains and the Pacific Ocean. When it becomes operational, the ELT is expected to allow scientists to directly analyze the atmospheres of planets outside the solar system, observe the formation of the first stars, and test some of the largest hypotheses about the structure of the modern universe. During observations, the ELT cannot remain stationary even for a single moment. To lock onto the faint light from exoplanets located many light years away from Earth, the entire telescope must continuously rotate with the motion of the sky, rotating horizontally in azimuth while simultaneously adjusting its viewing angle vertically in elevation with near absolute precision for many continuous hours. To achieve what seems almost impossible, engineers placed the entire telescope, weighing approximately 4,600 tons, on a giant azimuth rotation system nearly 50 meters in diameter, one of the largest precision tracking systems ever constructed in the history of astronomy. What is remarkable is that the entire telescope structure does not directly contact the metal rail system beneath it. Instead, it rests on massive rotational supports, where an ultra-thin hydrostatic oil film is continuously pumped under extremely high pressure between the contact surfaces. This fluid layer lifts the entire structure off its base, almost completely eliminating mechanical friction. It not only allows the enormous steel structure to move with extraordinary smoothness, but also acts as an advanced damping layer that absorbs nearly all vibrations generated by the drive motors. When all mechanical and optical components are perfectly synchronized, the ELT will reach the most important milestone in the life cycle of any observatory: first light, the first arrival of light. Planned for the year 2028, the entire massive system, from the 80-meter tall steel dome the nanometer precision hydrostatic tracking platform, and the primary mirror composed of 798 segments, to the chain of adaptive mirrors from M2 to M5, and the observational instruments, will operate together for the first time as a single unified machine. Photons that left distant galaxies billions of years ago will finally converge on the surface of M1 and be transformed into the first scientific data in the history of the ELT. This will not only mark the completion of a structure, it will be the moment humanity opens an entirely new way of seeing the universe. Rising from the desert landscape of Nevada as a massive spherical structure, the sphere has not only changed the way people build modern performance venues, but has also opened an entirely new direction for immersive entertainment architecture in the 21st century. For the first time, an entertainment structure has been designed as a city-scale immersive experience system, where structural engineering, display technology, and digital content operate as a single integrated entity. And from that success, the Sphere has quickly moved beyond the boundaries of Las Vegas itself to become a prototype for a new generation of entertainment megastructures that are beginning to emerge in major cities around the world. If you would like to continue exploring how mega projects like this are quietly reshaping the appearance of modern cities, don't forget to follow Mandarin Tech so you won't miss the next remarkable engineering stories ahead.